Hi students, welcome back to Learning Management System. Today we will discuss the second session of the unit 1 titled Pointers of the subject Data Structures using C. The course outcome of this first unit is to illustrate the concepts of pointers and dynamic numerical allocation with programs. In second session, we will discuss about pointer declaration, pointer initialization, and accessing the variable through pointer. Students, in the last session, number 1, we discussed about pointers definition, and there we discussed about the concept of memory, address of a variable, and how to access variable address using the address operator along with simple program executions. Okay students, so in this session we will discuss about these concepts. Coming to the pointers introduction, in C, whenever a variable is declared, we must declare its data type, whether it is integer type, float type, character, or double. We must declare its data type. Similarly, for pointer variable which contain the addresses that belong to a separate data type, we must declare pointers before we use them. So how to declare a pointer? Its syntax is data type, then pointer variable name, along with asterisk symbol. When compiler finds a variable along with asterisk, it declares that it is a pointer. This tells the compiler three things about the variable pointer name. That is, the asterisk tells that the variable pt name is a pointer variable and it needs a memory location, and pointer name points to a variable of type data type, and this data type, it is of any one of the data types like integer, float, character, double. In last session, we seen one example how pointer holds the address of a variable. Look at this example, revisiting the pointer example. This p holds the address of the variable quantity whose value is 179 and address is 5000, and 5048 is the address of pointer p. So let us see another example. So here are some different data types pointers declaration. First one is integer pointer, second one float pointer, third one character pointer, and fourth one is double pointer. So whenever these pointers are declared, for that data types, memory blocks are allocated. So let us see through the program execution how the memory addresses or memory locations are allocated to these pointers. Here my C compiler, let me write the code. What all pointers we used? Integer, x, float, integer p, float x, character c, double d, and let us print the size allocated or size of these pointers. Size of the pointers. That is p equal to percentage and x equal to percent float. Its format specifier for float is f, and c equal to percent c and d equal to percent d, and write the size of each pointer. Size of p, size of x, size of c, and size of d. Now let me run this code. So here you can see size of the pointers p equal to 8, c equal to 8, x equal to 8, and d equal to 8. So students, as we know, the size of the integer data type is 4 bytes. Float is 4 bytes. Character is 1 byte and double is 8 byte. But why it is showing p equal to 8, c equal to 8, x equal to 8, and d equal to 8? So the pointer size depends on the architecture of the machine or the computer. If the computer is of 32-bit memory or architecture, then the pointer will be having 4 bytes, because 1 byte is equal to 8 bytes and 32 divided by 8 is 4 bytes. So here the compiler on which I am running this code, it is of 64-bit architecture. So you divide 64 by 8, how much you will get? 8. That is why it is showing every pointer size as 8 bytes. Okay, students. Now we'll see pointer declaration styles. So come back to the pointers declaration syntax. So here it is data type followed by pointer name, and between pointer name and data type there is symbol asterisk, which represents the variable is a pointer. Okay, so there are three types of styles that we can declare the pointers. So pointer variables are declared similar to that of normal variables except this star symbol. And this star can be appeared anywhere between the data type and variable. So come here, This star can be appeared just after the data type. This is one style. Okay, students. Second style, I can write this star just before the pointer name. This is the second style. And the third one, I can write between the data type and pointer, leaving the spaces. So this is also a valid declaration of pointer. Keep in mind that there should be at least one space between the data type and pointer name. If you write like this, as sir said, pointer star can, the symbol can appear anywhere between these two variables, sorry, data type and pointer. If you write this style without leaving any space, this will give you the error. Okay, students. So there must be at least one space between these two. So here are some styles. So see here, the style one. Here, star is appear just after the int, leaving the spaces before the p. This is style one. In the second style, star is appear just before the pointer, or in the third style, you can write in between these two, that is data type and pointer variable name. So let us validate these styles pointers through program execution. Let me write these three style pointers. So first I am taking one pointer p1 and I am declaring this in the first style int p1, and this is second style, and this third one I am writing in between variable and pointer. And next I am printing the size of each pointer. Size of p1 equal to size of p2 equal to, and size of p3 equal to use the size of operator to determine the size of the pointers. Size of p1, size of p2, and size of p3. Okay, students. So let me run this program. So here it is given size of p1 equal to p2 equal to p3 equal to s8. As I already told you, size of the pointer depends on the architecture of the machine or the CPU. As this compiler, this compiler's system architecture is of 8 bytes. That's why it is showing 8. Okay, students. So we can have multiple declarations in the same statements, like we can declare the pointers of say similar data type in the same line. So here float pointer 1, float pointer 2. Such type of pointer declaration is valid. Also, you can declare pointers along with the variables. So x is a normal variable, whereas star pointer 1 is a pointer variable. So these two combinedly can be declared in a single statement. Okay, students. Now we'll see Initialization. So what is initialization? The process of assigning the address of a variable to a pointer variable is known as initialization. So what is the need of pointer initialization? As earlier we discussed, if we declare just pointers, it is having unknown address locations and it will not point to any valid variables. So to point the valid variables, we must initialize pointers to some variables. So here some points are noted with respect to pointers initialization. All uninitialized pointers will be interpreted as unknown memory addresses. Compiler ಏನು ಮಾಡುತ್ತೆ ಪಾಯಿಂಟರ್ಸ್ ಅನ್ನು ಏನಾದರೂ ಇನಿಷಿಯಲೈಸ್ ಮಾಡಲಿಲ್ಲ ಓನ್ಲಿ ಡಿಕ್ಲೇರ್ ಮಾಡಿದೀವಿ ಅಂದ್ರೆ ಇಟ್ ವಿಲ್ ಇಂಟರ್ಪ್ರೆಟ್ it as unknown memory addresses. So unknown memory address idre enagutte these addresses may not be valid addresses or they may point to some values that are wrong. So ನಮಗೆ one value ಬೇಕಾಗಿರುತ್ತೆ but this uninitialized pointer will point some other value. So since the compilers do not detect these errors, the program with uninitialized pointers will produce erroneous results. So compiler ಏನು ಮಾಡುತ್ತೆ runtime errors ಅನ್ನು these memory types errors ಅನ್ನು detect ಮಾಡೋದಿಲ್ಲ. So ಅವಾಗ ಏನಾಗುತ್ತೆ uninitialized pointers will produce the erroneous results. Results ಅನ್ನ wrong ಬರುತ್ತೆ. ಪ್ರೋಗ್ರಾಮ್ ಏನೋ ರನ್ ಆಗುತ್ತೆ, ಯಾವುದೇ ಎರರ್ಸ್ ಬರೋದಿಲ್ಲ. ಪ್ರೋಗ್ರಾಮ್ ಕಂಪೈಲ್ ಆಗಿದೆ, ಯಾವುದೂ ಎರರ್ಸ್ ಇಲ್ಲ, ಝೀರೋ ವಾರ್ನಿಂಗ್, ಝೀರೋ ಎರರ್ಸ್ ಇದೆ, ರನ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೂ ಏನಾಗುತ್ತೆ ರಿಸಲ್ಟ್ಸ್ ಅಲ್ಲೂ ಕರೆಕ್ಟ್ ಆಗಿರೋದಿಲ್ಲ because of uninitialized pointers. It is therefore important to initialize pointer variables carefully before they are used in the program. So ಪಾಯಿಂಟರ್ಸ್ ಅನ್ನು ಯೂಸ್ ಮಾಡೋಕ್ಕಿಂತ ಮೊದಲು ನಾವು ಇನಿಷಿಯಲೈಸ್ ಮಾಡಬೇಕು. Once a pointer variable has been declared, we can use the assignment operator to initialize the variable. So how to initialize a pointer? By using the assignment operator. Assignment operator ಅಂದ್ರೆ simply by writing this equal sign. This is called assignment operator. Okay students. So now we'll see how to initialize a pointer. So here I have declared one variable, that is quantity, and also I have declared one pointer star p. How to initialize this star p? By using the assignment operator. P equal to ampersand quantity. So whenever we write ampersand or address operator before the variable, it initializes its memory address to the pointer. So this is the correct way of initializing the pointer. So if compiler see this statement, what it will understand? It will understand that the pointer p is pointing to the memory address of the variable quantity. See this one. So after initialization, p points to the quantity. Okay. We must ensure that the pointer variables always point to the corresponding data type. For example, consider these many statements. So float a and b. A, b is float data type. Integer x star p. P is a pointer. And p is equal to ampersand a. So a is of type float, pointer is of type p, and integer type is pointing to the float data type variable. This will lead to error. This is a wrong because there is a type mismatch. So ನಾವು ಯಾವಾಗಲೂ ಇನಿಷಿಯಲೈಸ್ ಯಾವ ತರ ಮಾಡಬೇಕು? Pointers ಯಾವ ಡೇಟಾ ಟೈಪ್ ಇರುತ್ತೋ ಅದೇ ಸೇಮ್ ಡೇಟಾ ಟೈಪ್ ವೇರಿಯೇಬಲ್ಸ್ ಅನ್ನ ಇನಿಷಿಯಲೈಸ್ ಮಾಡಬೇಕು. ಸೊ ಹಿಯರ್ float is a variable which is assigned to the pointer star p. This is also wrong assignment, type mismatch. Okay, students. So let us see this through the program. See this program. Float I declared a equal to 10.5 and b. So here I have taken int x equal to 10 and declared pointer p. And I am initializing p equal to ampersand a, where p is the integer data type and a is a float type. So again, let me take p equal to star p, that is the point value to which p is pointing. And now I'm printing the value of p and b as well. So now let me run this program. See here, students. So I'm actually printing the value of variable which is pointed by the p. So to which p is pointing a. A value is 10.5, but what we are getting? We are getting some unknown address, right? Actually, it is not pointing to the actual value of the a, because it is wrong initialization. There is a type mismatch. Here also p is pointing to the b is pointing to the p, but here also we are getting some unknown arg memory value which is not expected. So let me show you why should we initialize to the same data type. So x is an integer type, p is an integer type. So I initialized p equal to x ampersand x. So again, once again, I am taking the printf statement p equal to %d star p. Now I run this program. See, p equal to 10. We got the actual value to which p is pointing. See, p equal to 10. So because it is a correct initialization, that is why we got the correct value p equal to 10. Whereas here in the first statement, we are not getting the correct value. That is why we should initialize the pointers in a proper way. Okay, students. So one should be careful while initializing the pointers. So you can take wide pointer. So wide is a universal pointer which will point to any type of variables like this wide star p. So wide has no data type, nothing to return. So it will point to the all data types variables like integer, float, character and double. Okay, students. So following declaration is valid. So you can declare a pointer along with its variable, and also you can initialize in a single statement. Ensure that x comes or the variable comes before the pointer. So integer x star p equal to ampersand x. This is a valid statement because x comes before p declaration. Whereas if you declare like this star p equal to ampersand x comma x, this is not a valid statement because compiler, when it sees ampersand x, so x is not yet declared. After the comma, x is declared. So compiler will be in confusion. So it gives the error. Okay. So this statement is not valid statement. We can also define a pointer variable with an initial value of null or 0. If you are not initializing anything to the pointer, then we can initialize the pointer to null. This is a valid. So let us see this through program execution. Let me write the code. Int x comma star p, and I am initializing this x to the pointer p, and let me print the address of the x, that is p equal to %d comma p. Just a second. Fine. So now let me run this code. This gives the address of the x. So first let me initialize the pointer p equal to %x, and later I will declare x. Let us see what will be the output. So here it is giving the error that x is undeclared, first use in this function. So compiler cannot see x because x is declared after the initialization. So this is not a valid statement. Okay, students. So the proper way of declaring pointer and initialization is first declare the variable, then initialize it with the variable. And next, let me show you, we can initialize null also to the pointer. So star p equal to null. P1 equal to d p1. So here I initialized p1 to the null value, and let me run this one. So it is giving p1 equal to 0. So initializing pointer with the null is a valid. Okay, students. Fine. So this is about pointer declaration and initialization. Now we'll see how to access the variable through the pointer. So we can access this variable using asterisk operator. It is also called indirection operator or dereferencing operator. Students, now onwards you call it as indirection operator or dereference operator. Okay. Consider the following statements: int quantity star p and n. Quantity equal to 179, p equal to quantity, and n equal to p. So here I initialized p to the variable quantity. Again, I assigned the value of p to the variable n. So let us see how this happens in the memory. So there are, when I declare the first statement int quantity star p and n, so compiler will assume that there are three variables, n and one pointer variable and one quantity. Coming to the second statement, that is quantity equal to 179. This 179 value is assigned to the quantity equal to 179, and that value is assigned to the quantity variable in its memory location. Coming to the third statement, p equal to ampersand quantity. So here I am initializing the pointer. So what happens? P points to the quantity. Okay, students. Then what is the last statement? Last statement is n equal to star p. So whatever the value is pointed by the pointer p, the same is pointed by the n variable. Hence, now the n is also having the value 179. So let us see this process through the program execution. Here I have written the code. Int quantity star p and n. I have declared three variables, of which one is pointer variable, quantity equal to 179, and I am initializing p equal to quantity. And also I am assigning the value pointed by the pointer to the n. And here is a printf statement. So let me run this one. So see here, students, all three variables value is 179 because all three are pointer is pointing to the memory address of the quantity variable, which is having the value 179. Understood, students? Whether concept is clear? Fine. Come back to the concept, that is pointer initialization. Now we'll see all these concept, whatever we discussed, we'll demonstrate that through the program. So here is a program. Write a program to illustrate how to access variables through pointer. Let me run this program in compiler. Okay, students, let us see this program execution. Here it is the program written. So I declared two variables x, y, and also a pointer ptr. X value is what? 10. And this x is initialized to pointer and y is equal to star pointer. So here value of x is, so here all the printf statements show at what address the variables are stored. Okay, students, let me run this program. See here, value of x is 10. Yes, what is initialized? X equal to 10. 10 is stored at the address -1376 last 664. That is x and ampersand x. So address of the x is this one. Okay, and here it is star p and ampersand x. Star p, here it is giving 10, means star p is having the value 10 because it is pointing to the address of the x. Next, third statement, 10 is stored at the address of, again same. So here ptr is equal to ampersand x. So both are same. Ampersand x or just pointer ptr. And coming to the 13 line number, ptr and star ptr. So star ptr means what? This is the address of the pointer, not the address of the x. See here, minus this 664, last three digits number I am reading. 664 is stored at the address 656. So this memory address of the pointer is different than the memory address of the variable x. And next, 10 is stored at the address again. So here, this one. And at the last, 10 is stored at the address again. So here, y is also showing the same address. Sorry, it is not same address. So it is having some different address. Okay, 660, and at last pointer is equal to 25. Now I modified the x value through the pointer. Previously it was 10, now it is 25, and print the x equal to x value, which is 25. Understood, students, how we can use the pointer in programs? So in today's session we discussed about pointers declaration, pointers initialization, and what are the styles of pointer declaration, and valid and invalid statements while declaring and initializing the pointers. Okay, students, these many concepts we discussed in today's session. So as of now, we will wind up this session. If you have any doubt or query clarification, please write us at lms.dtek@gmail.com. Thank you, students. Thank you for watching this video.